Okay. Chapter 5, day 9. This is a long chapter. It'll keep going, but day 9, here we go. What are the sum and product of the roots of a quadratic, and how do we use them? And what we're going to do is we're going to use them to write quadratics. Okay? So what are the sum and products of the roots of a quadratic, and how do we use those roots to write quadratics? So we can go forward and we can go backwards. So let's take a look. To help us through this, let's recall a little bit about quadratics. Okay? So recall, let's say I have a quadratic, all right? And I want to solve it and find the roots or the solutions, all right? We could factor the quadratic, make sure that it's equal to 0. We get two answers, all right? Now, these are the roots. Those are the roots. So if I said, what is the sum of those roots, I would take -3 plus -2, and I would get -5. Piece of cake. Product of the roots, I would take -3 times -2, and I would get 6. So, how can I find the sum of the roots? Sum and product of the roots? I could do the whole thing, get my answers, sum them, and product them. Okay? Let's take a look at another type of quadratic. Factors of 5 that add to 4 don't exist, so we have to do the quadratic formula. So I'll do a little shortcut here, but x equals opposite b plus minus the square root of, well, when I do b squared, which is 16, minus 4 times 1 times 5, I get -4 in there. All over 2 times 1. Okay. Well, we just learned that the square root of a negative number, we can now do -4 divided by 2 is -2. And the square root of -4 is actually 2i. Okay? So I don't need to do a whole unit on quadratic formula with i's. We just know that the square root of -4 simplifies down to 2i, and now we can keep going. Let's reduce this. So x will equal -2 plus or minus i. Now, if I want to find the sum and product of these, I better write them separately. So I've got x equals -2 plus i, x equals -2 minus i. All right, so let's sum these together. If I took a -2, added i, and another -2 and took away i, the i's would cancel and I would get -4. If I product these, if you remember from last class, these are conjugates, all right? So if I did a product, -2 plus i and -2 minus i, let's look at the product here real quick. -2 times -2 is 4, and then plus 2i minus 2i minus i squared. So that gives me 4. This cancels. Minus a -1 is plus 1. Gives me 5. The product would be 5. You may say, well, why are we doing this? Well, I wanted to take a look at a couple different quadratics to see if we can come up with a relationship between the sum and product of the roots given the equation. And let's see what we notice. The sum here was -5. That looks a lot like this number, but it seems to be the opposite sign. The product is 6. Seems to be that number. Let's see if that's the same over here. The sum of the roots is -4. Seems to be this value, but opposite sign. The product is 5. Seems to be that value. And so that relationship holds true for any quadratic. This sum appears to be the b value, but opposite sign. The product appears to be the c value. All right? The only thing is we have a 1 out in front of x squared here. If this number is different, you'll notice the roots are slightly different. And what happens is really the sum and product are the following. The sum, like we said, is the opposite of the b value, but divided by whatever the a is. And in this case, a was 1, so that's why it came out to be -5 over 1, which is just -5. And the product of the roots is just the c value over the a value. And if a is 1, then the product is the c over 1, which is just the c value, over 1, which is the c value. So the general relationship that you need to know for your class and your test and anything you do with this is the sum is -b over a, and the product is c over a. And so I star that because those formulas are not given to you, but you have to remember those. It's really super important. So the question might say, find the sum and product of the roots of a problem. All right? That just might be the question. What's the sum and product of the roots? Well, you could do the whole quadratic formula, get the answers, and then sum them and product them. Or, now that you know the relationship, let's apply it. The sum is opposite b over a. Opposite 2 over a. That was easy. Product, the c value, -10 over a. And you can leave it like that, or -10 divided by 5 we know is -2. Done. That's how you find the sum and product of the roots. Well, if that was the only thing we had to do, that would have been real easy, because I can do this for any problem. So we're going to have to think about how do we use them to write quadratics. And that's where this gets a little bit tougher. And this is where this is more of a problem that requires a little bit of thinking. So let's take a look. For example, let's say we know one of the roots. So if one of the roots of this quadratic equation is -2, so sometimes in a problem they will tell you some information. They'll say, hey, we've got one answer. They want you to find the other answer and tell me what this value is. So they're kind of keeping this a secret. So I look at what's given. They give me the b value. So I know from the b value we can find the sum of the roots. All right? So the sum of the roots is opposite b value over a. Well, the b value is -3, and opposite that would be 3 over, this is a 1. So I know the sum is 3. Okay, they told me one of the roots is -2. So 3 plus the other root has to be, I'm sorry, not 3 plus the other root. This root plus the other root has to be 3. Okay, because the sum equals 3. So the root that they give me plus the other root that I'm trying to find, okay, find the other root, that sum better be 3, because I know the sum is opposite b. Well, 2 plus what? I don't know, let's bring the 2 over. So add 2 to both sides. So the other root is 5. Now I know what the other root is, so that's part of the problem, right? It's part of my solution. Find c. C is the product of the roots. So product, which is the c value over the a value, which is 1, that has to equal the product of these two roots. So the other root, one of the roots is 5, the other root's -2. So that's -2 times 5. Well, c equals -10. So now I found the other root and c. And I did that because I know, if I know this value, I can work with the sum. Let's see what other information we might have. Let's say one of the roots of this is 1. Find the other root, and now the b value. Well, I can't use sum anymore initially because I don't know this, but I can use product. So the product is 4 over 1, which is just 4. So the product. So I have a number, right? One of the roots is 1, so that 1 goes right here, times the other root. That would equal 4. So 1 times some number, the other root is 4. Well, divide both sides by 1. And the other root equals 4 divided by 4, which is 4. I have found the other root. Now I have to find b. Well, in order to find b, I need to use the sum. Okay, so b is related to the sum, so let's find the sum. One root is 1, the other root is 4, the sum is 5. So that sum is negative b over a. Well, that's 5 over 1. So opposite b is 5. So b must be negative 5. If opposite my b value turned out to be positive 5, b is negative 5. It is just, you gotta keep track, it's going to be the opposite sign. So whatever my sum is, the opposite sign then is my b value. Okay? So here's another way they like to use it. Let's say we want to write a quadratic equation with coefficients given the following roots. So they tell us both roots. We have nothing to go on, we just know the roots. All right, so step 1, you need to find the sum and product of the roots. Okay, so easy cheesy lemon squeezy. Sum 6 plus 2 equals 8. Product 6 times 2 equals 12. And again, I'm going to write these as a fraction because isn't the sum equal to opposite b over a? And the product is equal to c over a? Well, if the sum is opposite b over a, it looks like a might be 1. Product c over a, it looks like a is 1 because they have the same denominator. If they didn't, you'd have to get a common denominator to find a. But a is 1. B, well, 8 is opposite b, so b must be opposite that, negative 8. C must be 12. And if I'm going to write a quadratic equation with those roots, then I will write 1x squared, so I don't even put the 1 there because it's implied, minus 8x plus 12. Now, if I'm going to write a quadratic equation with those roots, I have to put equals 0 down. That's a quadratic equation with those roots. It has to be written in ax squared plus bx plus c equals 0 form. So find sum and product. From there you can get ABC and then write it. Last one to look at. This is really neat. So they give me one root, 3 plus radical 5. Well, if we remember the quadratic formula, it goes x equals opposite b plus or minus the square root of. So if one answer is 3 plus this, the other root must be the conjugate, 3 minus radical 5. They're going to expect that you know that if one root is 3 plus this or 3 plus I or whatever that deals with square roots, the other is the conjugate. So here we go, sum them up. I got 3 plus radical 5 plus 3 minus radical 5. 3 plus 3 is 6. These cancel out. Sum is 6, and again, I'm going to write it over 1. Product. 3 plus radical 5, 3 minus radical 5. Now, hopefully we remember when we did radicals that the conjugates will not have a middle term, but let's take a look. So, FOIL, 3 times 3 is 9, minus 3 radical 5, plus 3 radical 5. Again, doing my first, outer, inner, and now let's do the last. Positive times negative is negative. Radical anything times radical anything is the anything. Middle terms will drop out. 9 minus 5 is 4 over 1. So again, it looks like my A value is 1. My B value, well, sum is opposite B over A. Opposite B, so if that's 6, my B value is negative 6. My C value, my A value is 1. My C value, well, I know the product is C over A, so C has to be 4. So what do I have? I have 1x squared, so I don't really put the 1 there, that would just look silly. Minus 6x plus 4 equals 0. And that is my quadratic. So, what are the sum and product of the roots? Negative b over a and c over a. And how do we use them to write quadratics? Well, we have to go through this process of finding the sums and the products, identifying A, B, C, and write the relationship, or the quadratic equation. Equal to 0 though, because it says where are the roots. If you wrote equals y, no good. If you wrote equals fx, no good. You have to write it equal to 0, because it's saying I want a quadratic equation whose root is, well, the roots are where it's equal to 0. And that's it.